Good morning, John Gilkison, Aero Stealth here. It is Friday, September 15th, 2023, and I tried to shoot this video yesterday, and I did a 4-minute, 11-second video and posted it, but I had to take it down because it had a substantial math error in it. Which, try as I might, before I shot the video, I didn't catch it. So here we are again today. Wish me luck. This is all based on a previous video. The video was grams of electricity equals 75,000 gallons of gasoline. And the basis of that was just using Einstein's theory of relativity, his formula that is, not a theory, E equals mc squared. And that's where you just convert mass into energy. And it's all converted into the electromagnetic spectrum. And so I include electricity in the electromagnetic spectrum. So here we'll go over it. This what I'm doing on the 23rd. I'm going down to the EV car show. It's being held at this year at the Brannigan Library parking lot. In previous years, it was held on the plaza downtown Las Cruces. Anyway, hopefully this will be a better venue. So I've got a couple poster boards on this conversion of electricity into mass. Now here's the thing about this. If you fill your car up with gasoline, you might increase the weight of the car by over 100 pounds easily. But it's not a substantial increase. But if you take an electric vehicle that's has a zero state of charge and you weight it, and then you completely charge the electric vehicle up to 100% SOC, and you weight it again, you would be hard put to detect any change in mass whatsoever. And the reasons for that is electric vehicles only hold 2 or 3 gallons equivalent of gasoline and electrical energy, and that turns out per gallon equivalent it's 1/75 thousandths of a gram, using the E equals mc squared formula. So the car has literally no increase in mass, which is a good thing considering the battery itself might weigh 1,000 pounds or more. So we don't need any extra mass just from fueling the vehicle or powering up the vehicle. So, however, the import of all this has nothing to do with the electric vehicle's performance, but it has to do with the well-to-wheel efficiency for society. In other words, to extricate 75,000 gallons of gasoline and crude oil and ship it around the planet, refine it, ship it, so forth, takes tremendous amounts of energy. 3 or 4 times the energy that's in the fuel itself. And when you have a power source for an electric, like an electric vehicle, which has almost no mass, it's very easy to ship it around the planet. It's nothing to ship a gallon of electrical energy equivalency over our power lines, because they only weigh 1/75 thousandths of a gram. So it's just, I wanted to shoot this video because it's a new way of thinking about things. And so here we are. Here's my poster boards. See if we can't get them in here. Now up at the very top, I just say that the E equals mc squared, 37.4 kilowatt hours, mass equivalent 1/75 thousandths of a gram, and that This includes charging efficiency. There's only 33.7 kilowatt hours in a gallon of gas, but at 90% charging efficiency, it takes 37.4 kilowatt hours to put a gallon equivalent into an EV. Skip ahead here. So, if all this is true, then 1 gram of electrical energy is equivalent to 75,000 gallons of gasoline. And this amount of gasoline would require a cylindrical tank 24 feet by 24 feet. And this is your tank over here. And it's 24 feet by 24 feet will hold 75,000 gallons with a little headroom to spare. So this was my interest. I just think that 1/75,000th of a gram is very abstract to people. So I wanted to convert this to a whole number that people could be used to thinking in. So 1 gram. Now these 2 pills, these are vitamin pills. And I had to get 2 of them to weigh 1 gram. But these 2 pills are your equivalency of mass. And this tank here is your 75,000 gallons, and here's your man for scale, 6-foot person. And so that's it. Now, since my Chevrolet Bolt I've averaged up to 126 miles per gallon in it. However, 120 miles per gallon is a middle figure, and you can do plus or minus 6 miles per gallon. That should bring you up to 126 miles per gallon, or down to as low as 114 miles per gallon. But if you multiply 120 miles per gallon times 75,000, you end up as 1 gram of electricity could power an EV like my Chevrolet Bolt for 9 million miles. And that would be plus or minus 40,000 miles. So this is about, let's say you owned an electric vehicle for more than a decade. You could rack up, let's say, 300,000 miles on it, which would be a lot. However, this 9 million miles, 1 gram here, this 9 million miles is 27 times that. And the plus or minus 40,000 miles is about twice as much as people drive in a year, up to 3 times. So there you have it. It's just a visual representation that's meant to get people to think about the fact that a switch to electric vehicles are, not only do they not have a tailpipe, a cancer pipe, they don't have an engine bay with a planet-killing internal combustion engine on it, and the electrical power can be delivered to your garage to charge it for very little expense to move it compared to what it takes to move crude oil and gasoline around. Not only that, you even have to go get it at a gas station. I don't have to go anywhere. I just park my car in my garage and I refill the tank. And also I have 5.1 kilowatts of solar, not too far away. It literally can charge it not using any grid power, and it's be pure renewable at that point. But that's another video. So anyway, wish me luck with this display. It seems to be a little obtuse to people, and it does require some explanation. So this is why I've got my poster boards up. Maybe I can get some people to see these at the EV car show. Take care, everybody. I'm going to upload this and call it a morning. Bye-bye.